All right, so let's compare our first triangle to our second triangle. What do we have marked congruent?
The side, angle, side.
A side, marked congruent to a side. A right angle and a right angle. How many degrees are right angles? 90. So is 90 congruent to 90?
Yes.
Yes. And then we have a side marked congruent to a side. Is this side angle side?
Yes, ma'am.
Yes. In order for it to be side angle side, where does the angle have to be? Included between the two sides. Perfect. Number 2, we have 3 sides congruent. So what theorem matches that? Side, side, side. So this is yes by side, side, side. All right, so number 3. What do we think number 3 is?
Yes.
Do we agree? Yes. I agree. So yes, side, angle, side. Number 4 is what kind of triangle? Right triangle. What is the first thing? What is the first thing you should ask yourself if it's a right triangle? If it's hypotenuse leg. So let's check. Do we have the hypotenuse marked congruent to the hypotenuse? Yes. Where is the hypotenuse always? Across from the right angle. Okay. My students always said that it kind of pointed because it's got that. I don't know. So here's my hypotenuse marked congruent to hypotenuse. All right. Do I have a leg marked congruent? Yes. A leg to a leg. So this would be yes, they're congruent by hypotenuse leg. Yes, sir.
What was the first one?
Because the hypotenuse. Good question. He said why.
Two marks are.
Yeah, so he said, why isn't this hypotenuse leg? Because this is the hypotenuse and it's not marked congruent. It's a good question. Number 5, you actually have not learned this yet, but it appears, Noah, we have an angle marked congruent to an angle, a side to a side, and an angle to an angle. How many of you have taken a look at the name of this lesson?
Angle, side, angle.
Angle, side, angle. So guess what? This is yes because of angle, side, angle. Don't get upset if you didn't get that right. You just haven't learned it yet. It just happened to be here. Who does what?
What is this for?
Proving triangle congruence?
Besides teaching.
Architecture.
Besides architecture and construction and things like that.
Being a geometry teacher.
She said
And
that.
besides teaching.
I know. All right, here we go. It also kind of gears us up for similar shapes. Similar shapes are shapes that are like the same structurally, but one of them, sorry, I'm trying to do it for you.
That's a pretty good triangle.
Appreciate it. But one of them is larger than the other. So like this is the next, what chapter are we in? 5? This is 2 chapters from now. That makes sense? They're not going to be congruent. Congruent means all the sides and all the angles are congruent. So here the angles look congruent, but the sides aren't congruent. This would be called similar. Similar.
So how long are we talking about triangles?
A lot of geometry. Chapter 9 is all about triangles.
Can we learn
But
about-
chapter 8, focus. Chapter 8 is over similarity of all shapes. I just use a triangle. But this like brings us to similarity. That's why we learn this first. Okay. We do have a whole chapter over quadrilaterals. What's a quadrilateral?
It's like it has 3 or more sides.
3 or more sides. Nope. 4
4
sides.
more sides.
4 sides. Exactly. 4 sides. So we go over squares, rectangles, rhombuses,
I think
kites.
rhombuses have 5 sides.
No, they have 4. I'm still a geometry teacher. Here we go. Number 6. Number 6. All right, so what do we have marked congruent? Side, angle, side. Sorry, I thought you said it the other way. Yes, side, angle, side. So flip to the front. We're going to talk before we begin our notes. We have learned 3 theorems that prove triangles are congruent. So I want you to write what I'm writing. Prove congruence. We've learned about 2 that are not. And I will reiterate them because I'm going to flat out ask you on your test to name the ones that prove triangle congruence. Do not. That's not a P. Prove. So we're going to talk about the theorems that do prove triangles are congruent. So you're writing this in randomly, not it doesn't go in your notes yet. All right, so can anybody tell me what theorem we learned that proved that triangles were congruent? We said side, side, side.
Side, angle, side.
Side, angle, side. We're going to pause there for a second. Side, angle, side. Where did the angle have to be? Included. So between. All right, what was the last one we learned? Hypotenuse, what? Leg. And then your last two are at the top of this page. ASA, which stands for? Angle, side, angle. And then AAS, which stands for? Angle, angle, side. All right, so we're writing this down somewhere. So what two theorems do not prove triangle congruence? What was the one I told you explicitly? Angle, side, side, which I'm going to write side, side, angle. Here's the other one. Angle, angle, angle. They do not exist. They do not prove triangles are congruent. And I will show you why. All right, so take my two triangles, for example. All right, would you say that these angles are congruent to each other? All I did was I copied it, and then I made the second one larger. So you see they have the same mistakes on them. So all of the angles are congruent. Are the sides congruent? No. So are these two triangles congruent? No. So angle, 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 AAA, does not prove the triangles are congruent. And then SSA obviously doesn't either. So we're going to talk about this. Today, we learned two new theorems, and here's the main thing you need to know about both of them. How many angles are in both of these theorems? Two angles. What changes in the name? Where the side is. So look at where the letter S is in angle, side, angle. It's between the angles, yes? So guess what happens when we learn about angle, side, angle? The side has to be included. The side has to be in between. Whereas angle, angle, side, the side will not be in between. Angle, angle, side is the same as side, angle, angle. So you could call it either one of these. Okay, so we're going to talk about both. Take out a highlighter. You're going to take your highlighter. It says if, don't highlight anything yet, if two angles and the included side. You're going to highlight the word included. What does included mean? Between. All right, so look at where it's included on my picture. My side is included between the two angles. This is what makes it angle, side, angle. Angle, side, angle. All of my information is on one side of the triangle. Okay? So if two angles and the included side of one triangle are congruent to the two angles and the included side of a second, then the triangles are congruent. So this should say angle, side, angle. All right, so let's do this. If angle A is congruent to what angle? We're filling in the blanks. Angle A is congruent to angle D. Side AC needs to be congruent to what side? DF. And then angle C needs to be congruent to angle F. Because of this, then we can conclude triangle ABC is congruent to what other triangle? DEF. All right, so we're going to use this in the problem below. Noah, go ahead and read the top line to me.
In the diagram,
Line, yep.
line AB is perpendicular
Perpendicular.
to line AD, DE is perpendicular to AD, and AC is congruent to DC. Prove triangle ABC is congruent to triangle DEC.
Perfect. All right, so it says prove. So y'all think about this for a second, because some people don't understand how to answer these problems. Y'all look at me.
Dustin.
If I said prove that Jamari plays basketball, listen. If I said prove Jamari plays basketball, and you looked at me and said, yes, he does. Does that prove anything?
No.
No. Well, that doesn't prove anything. It just says yes. Cool. Awesome. So, but that would be proof, would that not? So here, when we prove, we need to look at what is congruent to what to decide that the whole thing is congruent. So let's look. Do we have angles that are congruent?
Yeah.
We do. I have angle A and angle D, so guess what we should write?
Angle.
I'm going to write A. So angle A is congruent to angle D. All right, what else do I have congruent? Sides. All right, so I'm going to write S. Side. I have side, what? AC. What is AC congruent with? DC. It's okay. So it appears as though I only have two pieces of information. Where's the third one coming from?
Vertical angle.
Vertical angles. Remember, vertical angles are congruent.
That was a good job, Miss Hacker.
Miss Marshall is my name. Thank you. So before you go name these, can I just say angle C?
No.
How many angles are at angle C? Two of them. So we need to actually name them. When you name them with three letters, where would C have to be? In the center. Yep. So we're going to say ACB just because I want to. Angle ACB is congruent to, what would we name the other one? DCE. So, what theorem did we just prove?
ASA.
Angle side angle theorem. So again, where is the side in comparison to the angles?
In the middle.
In the middle. So please make sure when you learn the second one, angle side, it's different. This one, the side is directly between your two angles. Yes, dear.
So for the vertical angles, we have to.
You don't have to write that they're vertical angles.
No. I'm asking to classify them. Like, do we have to put all three letters? We can't just do angle side.
Yes, you would have to do three letters. Because if you said angle C is two different angles.
That's why you put angle.
That's why you would put ACB and DCE. It's specific to the angle. All right, so we flipped. Take out your highlighter. Well, actually, first, go ahead and name your theorem. Theorem 5.11 is angle side. It can also be named side angle. So angle side is also known as side angle. So in this one, we still have two angles, but this time the side is non-included. So go ahead and highlight non-included, and then the two sides.
What?
You need a highlighter for this class.
I know. I left my highlighter at house because I was watching your video. Your notes video.
That's good.
That is good.
So if two angles and a non-included side of one triangle are congruent to the two angles and the corresponding non-congruent side of a second triangle, then the two triangles are congruent. So what would angle A have to be congruent with?
D.
Angle D. Angle C needs to be congruent with angle F. And then side BC is congruent to EF.
Why are you trolling? Scared me.
Trying to get my steps in. So that means triangle ABC is congruent to DEF. All right, so let's use that. It says we have given angle A is congruent to angle D, angle C is congruent to angle F, Side BC is congruent to side EF. Let's prove that the triangles are congruent. Let's start with our information. Do we have sides or angles marked congruent? Yes. Well, so let's list them. What would you like to list first?
I got it.
Sure. Angle A would be congruent to angle D. So I got a pair of angles. Angle A is congruent to angle D. All right, we're just going to keep going around the triangle. What else do I have?
Angle C.
Angle C. So angle C is congruent to angle F. Angle C and angle F. See here, Cole, you don't have to write 3 letters because there's only one angle at each. Make sense?
But they're not vertical angles.
And they're not vertical angles, no. So vertical angles, most likely you'd have to write 3 letters. All right, and then what else do we have? We have a side. Side B. What do we say? BC is congruent to side EF. All right, so how do I decide if it's angle, side, angle, or angle, angle, side? Where is my side? Is it between my 2 angles? It's not. It's across from my angles. So this would be angle, angle, side. All right, so we would write angle, angle, side theorem. So we write all of this proof in angle, angle, side theorem. Go ahead and flip.
How are you going to get your steps in?
Here we go. Can the triangles be proven congruent? Let's test it out. So looking at your paper, I know you can't really see on mine, so I'm going to outline them for you. This is the next page. I promise you have them on your notes. All right, so let's look and try to see if we have things congruent. So I have an angle marked congruent to an angle. We agree?
I agree.
We also have a side marked congruent to a side.
But they're vertical angles.
And we also have vertical angles. So will this be angle, angle, side, or angle, side, angle? Which one?
Angle, angle, side.
Angle, angle, side, because the side is not between the 2 angles. Good. Letter B, what do we have?
3 angles that are congruent.
3 angles that are congruent. Is angle, angle, angle a theorem?
No.
No, so this is not congruent.
That's unfortunate. They look pretty congruent to me.
There's no proof. All right, now we look on our next one. I see we have an angle congruent to an angle. An angle congruent to an angle. Is that all I have?
No, you got a side in the middle.
I have a side they share. So is this angle, side, angle, or angle, angle, side?
Angle, side, angle.
Angle, side, angle. A side is directly between my 2 angles. So not that one, not that one. Oop. All right, here we go. Well, I'm just trying to make sure you know. I'm going to call each of you. Noah. I've already called you today. Ian, help me with number 1. What are we thinking? What do we see that we have congruent? What are these? Angles. We got an angle congruent to an angle. What else do we have? A side. Which one? The middle one, the side they share. Good. And then what's the last thing I have? Angle. So is this angle, side, angle, or angle, angle, side? Angle, side, angle. Perfect. So yes, these are congruent by angle, side, angle. Go ahead and help me with the next one, Justin. You've got this. Talk with me. What do we have? I see an angle. Good. What else do you see? Which side? This one? Yes? Alright, what else do you see? Another angle. So is this a theorem? Which one? Good. Angle, side, angle. Perfect. Alani, you want to help me with the next one? Go ahead and help me.
Okay, I see a side.
Okay, good. I see it too.
I see an angle,
Okay.
and then two more angles.
Which one?
In the middle.
In the middle? Why? Because they're vertical. Good. So is this angle, side, angle, or angle, angle, side?
Angle,
Angle, angle, side. Or you could also say side, angle, angle. Same thing. Perfect. All right, last one. Colt, you got this. What do we have congruent?
We have two sides.
Two sides congruent. Do we have any other information?
No.
Do we have any vertical angles?
No.
Do they share a side?
No.
So are these congruent?
No.
No. Perfect. All right, so I'll explain to you what we're doing for classwork.